Okay, so I saw a video of a kid programming this exact question, and I think that it's somewhat simple. So I think I'm gonna try it out. So let's give it a shot. First, I'm gonna do what the kid did and calculate whatever this is. So 2 to the power 31, is that what it is? Yeah. Comes out to this number. And it said -1, so yeah. Constraints is the number's gonna be 0 to whatever this is, -1 or whatever. Now, let me explain my approach. And by the way, I'm a software engineer, not an amazing one, but works. So my thinking is that given a number like 5, 6, 7, 8, 9, this number is always gonna be the number itself unless this number is 1, because then it'll be 11, right? Or I guess the same works for 12, 13, 14, 15, 16, 17, 18, 19. Okay, so if this number is 1, then we're gonna have to redo this part, but essentially this is never gonna change after that. This is always gonna be 700. Yeah, this is always gonna be whatever 100. This is always gonna be 1000, right? Because we're not gonna do 1100. This was always gonna be, so this, so we're gonna, we're gonna essentially repeat this part for the next, whatever, shit, there's a lot of digits. But we're gonna repeat the next bit for this. Actually, come to think of it, it should be the same thing, right? Because up to 100. Yeah, wait a second, let me think about this. So let's say we have a number. I'm gonna type it down because funny font. But something else. Yeah. So let's say we have this number. So this number is always gonna be 648, 483, 147. Huh. Didn't think about that. Yeah, that makes sense, bro. Yeah, and then you just append 1000 here. You append million here and billion here, and that's about it. Yeah, that should be pretty easy. So I've got some wires hanging loose. So I think what I would want to do is write the code for this. And this is also just always going to be the same thing, right? Because what I said here, this is always going to be 21, 31, 91, yeah. Yeah, it's the same thing. So it's just this part that you have to account for. Otherwise it's simple. So what we're gonna do is we're gonna take the integer and we're gonna break it down into sets of 100, I think. So think of it like this. Also, I just want to preface this by saying I didn't think about this problem at all. I just saw the kid coding it with his fancy keyboard and I thought, hey, this is a leetcode hard question. Doesn't seem that hard. It seems pretty easy. So we have an int. Alright. So if we divide this by 100, we're gonna get, or sorry, if we take the remainder of whatever is 100, like a remainder operator with 100, so we get our first 3 digits. Or no, 1000. Then we get our first 3 digits. Right. So then we can convert it to a string and we can check the length of the string. If it's 3, actually the length of the string doesn't, length of the string and remove all zeros, I guess. Right? Yeah, that makes sense. That makes sense, yeah. So num is what we have. So let's do, what do we want to do? We want to take, let's do sets. This is an empty list. Alright. And let's do temp equals num while temp sets plus equals temp 1000 temp equals 1000. So what I'm doing here is I'm just creating sets of 3 digits. Okay. So let's check what we've got so far. Just to see. I'm expecting a list with, this shouldn't run for so long. But I'm expecting a list with at least one element. What? Really? Memory limit exceeded? We didn't even do anything yet. Well, I suppose we don't have to make sets. I guess we could just iterate manually. Okay. Okay. So we could iterate manually. Okay. So this approach doesn't work. Okay. 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 Let's think about it. Well, okay, let's say final is gonna be a string. Can even declare it, I guess. String. That's what our final number is, alright? And if num equal to 0, return 0. Because I don't think there's any other scenario where you need a 0. Right? You're not gonna say 0, 1 or anything like that. Yeah, so if num equal to 0, just straight up return 0. In fact, we don't even have to initialize. We could just put that up there. Okay. So now we've got our word. Okay. So we have to take the last 2 digits. So we're gonna do a somewhat null check here. If length, okay, no, we're also gonna need the length of num length equals, I guess it, let's follow some coding standards. So okay, yeah, so s final string final integer num length equals length of the number. All right. And if I num, you cannot. If I num length equal to 1, if num equal to 1, I think it would be easier to just have like a little dictionary ready earlier, right? Yeah, it would be easier to have a dictionary ready. in the beginning. So we could do, I don't 100% remember how Python dictionaries went, but if I recall, I think it was something like 1. Let me just quickly Google this. Python dictionary syntax. So, if I'm remembering it correctly, it's like a JSON. Yeah, it's like a JSON. So we want to do this the other way around, I guess. 1. Yeah, so I think what we would want to do is, yeah, okay. Okay, so we would get object ones. Okay, object. Okay, wait. So okay, here's what I'm thinking. We're gonna have one dictionary which has 1 to 9, another dictionary that has 20 to 90, I guess, and then it's dictionary that has the numbers from 11, oh, but 20 as well. I forgot about that. Okay, so we're gonna have a few dictionaries then. 10, yeah. 90, 80, 70, 60, 50, 40, 40, 30, 22. Yeah, so it's not gonna work. Not necessarily gonna work. Okay, so we're gonna have one from 10 to 90, one from 11 to 19. Yeah, 10 to 90. 10 to 90, I think that gets rid of the need of having this. Like, yeah, then that kind of gets rid of this, right? Yeah, it gets rid of this, because 10, oh, no, yeah, it does. Okay, yeah, so 10 to 90, 11 to 19, and then we just have 1, 2, 3, 4, 5, 6, 7, 8, 9. So that way, if we come across, what is that? If we come across like 1, 1, or let's just do singles for now. If we come across like 7, that's 7, that's 70, 77. If you come across, that's, oh, got a 1, so it's gonna come from here, which is 19. And there's no edge case there, I guess. And if it's a 0, then whatever we have here, it's gonna come from this one. So 10, 20, 30, 40, yeah. So that should do 0 to 9, that should do 1 to 99. Because there's no scenario where you have 0. Okay, cool. So yeah, so I'm gonna have a list for, so we're gonna do O zeros. First let's do if num equal to 0, return 0. Okay, now that we have that out of the way, we're gonna do O ones equals a dictionary, and in this dictionary we're gonna have 1, 2, 3, 4, 5, 6, 7, 8, 9. We're gonna stop at 9. I don't remember the syntax, but I've also not done Python in like a year, I guess. Don't get much time outside of my job. But let's see. I don't think this is a super optimized approach, but it's actually not that bad, I guess. Also, I'm just doing this to get an answer that works. I might try to optimize it a little bit, but I just wanna. I didn't see how long the kid's video was, but I'm hoping I can do it a little bit faster than him. Although, I'm starting to doubt it, but hey, haven't done leetcode in like a year, haven't done Python coding in a year, haven't even done competitive coding in almost a year. Just like business stuff. Right, so we've got this one down, the one. So now we want to do, I guess we want to cover this, right? Because that's more broad. So we're gonna call that O tens equals, and O here is just, I'm just gonna put a little suffix, oh sorry, prefix, prefixes I'm using, and we've got O equals object like an array, dictionary, list, etc. I mean, I guess a lot of these are the same thing in Python. S equals string, I equals integer, B equals boolean, but I'm not even sure I'm gonna use that, so let's figure out what we want to do. Okay, and I think we can just copy and paste this here. Okay, really? Wait, I think I can do this. Yeah, 0. Cool. Is it Alt? Is it Shift? Yeah. Okay, it doesn't work. Let's just... oh, okay, yeah. This would definitely not have worked another way. I don't think there's a more optimum. I mean, it probably is. Some kid probably sat and figured it out. That kid probably sat and figured it out. But I think we've got this. Okay, then we've got our doubles, let's call it. Yeah. So once again, we're gonna copy paste that, and we're just gonna do 1 there, 11, 12, 13, 14. I'm now realizing that a lot of shows have, or a lot of fiction has like characters that don't get a name and they just get assigned numbers, like Stranger Things, 11, House MD, 14. Sure, there's others that I cannot think of. Sorry, 13, I guess, not 14. Juror number 12 and all that. I mean, you know. 18, I don't think that's how you spell it. 18, 17, 19, 16, 15. Okay, so that should cover pretty much all of the areas, and then we can do one more for... yeah, we can do one more. So I'm thinking, like as you iterate, so we're gonna iterate backwards, right? And I'm thinking what we can do is, like, every time we hit 3 digits, we can just add like 100, 1,000, million, billion, and just keep that in a list or something. I think a list makes more sense for that one. Oh, positions equals, and this one's just gonna be a list. 100,000 million and billion. And if I remember correctly, that's the limit of what we have here, right? So now it's just a matter of iterating through. So yeah, so we had a string somewhere. So now what we're gonna do is, okay, so we're gonna iterate backwards through the list. So while num, okay, and we're gonna also have I equals len, or is it gonna be a little less than that? I think it's gonna be less than that. Len num minus 1. This is generic. I'm not gonna put the suffix there. Even if I would, it would just be I. So you know, it'd be weird. So while num. So we're starting from the last position. We want to peek at the next one. I think I want to do it something like while num and O positions, something like that. So for example, yeah, and we're also gonna have to have s final answer equals an empty string, right? So what I'm thinking we're gonna do is every time we cross a milestone, we're just gonna decrease this, and then you know, I'm thinking it's something like if you've detected a change, then we can reset. It would be easier to pick a function for this, but it would be easier to pick a function for this actually, but it would be bigger in terms of memory. So since that seems, yeah, let's return. Let's just quickly run this and see if I made any syntax errors. Object of type int has no length. Okay, right. Run. Okay, so it return 1. Let's try that, just to see if we're making it through even, because I don't remember the syntax 100%. So you know, just to see if I'm actually getting the syntax right and like declaring everything correctly. I think we're good to continue. So what I'm thinking we'll do is digit equals digit equals, okay, yeah, I think what would make more sense is to have, like, you know, I position, no, we wanna, actually we could while num, so that means we're gonna drop that. Yeah, no, so we wanna initialize this outside. I position tracker, or I guess that would be a pointer, not necessarily a tracker. One sec, let me take this. I'm thinking of doing like a position pointer sort of, so that we go 0, 1, 2. And that way, yeah. So that way it's like the ones place, the tens place, the hundredth place, and then we like reset and we kind of, you know, yeah, that works. Position tracker equals 1. Let's do 1. So 1, 2, 3, and then we reset. Yeah, just to make it a little easier, right? Because why to complicate things? If I position tracker is greater than 3, yeah, if it's greater than 3, then what we want to do is I position tracker equals 1. We want to reset it. If I position tracker equals 1, okay, now let's do the 100 scenario, right? Equals 3. Yeah, if it equals 3, that means we're at the 100th position. So what we're just gonna do is digit equals num remainder 10 and s final answer equals equals O ones digit as a string plus a space plus O positions. This is gonna be kind of like a stack actually. 0 yeah okay, we're gonna have to reevaluate after that as well, but okay, if position tracker equals 3, so digit equals, we take the digit as final answer equals this plus O position 0, which is a string anyways, plus space plus as final answer. So it will go wait, no, it would go 100. It would be, this would be 100 every time, right? Yeah, it would be 100. Yes, this would be 100. But that gives us an issue because the first one is gonna be 100, 100. But then the next ones are always gonna be 100,000, 100 million, or there's an easier way to do this actually. What if I just remove the 100 and then add it here? Well, then I would have to add another check, right? Okay, so this is definitely a better way. But then so basically what I'm thinking of doing is every time we're going here, So it would be 1, 2, 100, 3, 400,000. See what I mean? 100 and 1,000. Bam, bam, 100 million. So we need the 100 everywhere. But we don't need this 100. Because, like, this logic is already going to take care of it. I don't know if I'm illustrating this well. So, like, something like this would make sense. Or wait, what if I just 100 space 1,000 space? Yeah, actually, yeah, that makes sense. I could just deal with the space here. That makes it easier, right? 100 plus oppositions 0. So that way, if I'm at, let's say I'm at 763, so I'm at the third position, which is this. So S final answer equal, so digit here would be 7. Then S final answer would be 7 plus space plus 100 plus nothing plus 63, which is already in there. And let's say I'm at 763,241, so this part has already been covered. And then we've iterated through, so this part has already been covered. So then, and I've popped the first one, so now 1,000 is what we have in here. So now it would be 7 space 100 plus space 1,000, 700,000, 63. Wait a second. 763,000. 763. Yeah, so I don't need this. I don't need this. That was very clever otherwise. No, I do need this, but where do I need this? I don't need this here, but I do need this. Okay, wait. Okay, so it's just gonna be 700, whatever. Yeah. So where do we add the 1,000 is the question. So if you're at your last position, so digit equals num by 10. So in this case, num by 10, so it's 700, and then this part is already taken care of. Correct? Correct. 763,000. Yeah, it's okay. So 700. So now, first thing we're gonna do is num equals num divided by 10, floor division by 10. Yes, floor division by 10. So at this point we've gotten rid of everything, so it's just the 7. When you do floor division by 10, so you get 0. Num equals floor division by 10. I position tracker equals 1 because we're resetting. If num greater than 0, S final answer equals, yeah, that makes more sense. Positions 0 plus S final answer. So yeah, that makes sense, because in this case, if it's 0, okay, cool. Yeah, we don't need an else in this case because it would break out anyways, so we're good. I think this is good. let's just run. Wait, okay, so let me exit all this. Return as final string. Not sure if I need this part anymore. Final answer. What is it? Return. Is this correct? Yeah, this is correct. Yeah, do I need oppositions anymore? Because once I run out of a billion, for example, which case does that even happen in? I think this is redundant. Because the number, like, let's say I just did 100 million, like the million is already covered. So then we divide this, it becomes 0. I position tracker equals 1, numbers greater than 0. Yes, let's say there's one more digit, so 1 billion. Then we'll add billion. Can get rid of this space. So we add billion plus whatever, so then in the next one we do 1 billion and then we're done. So yeah, the position is redundant. Position check is redundant, so just while num. If position tracker is greater than 3, which is not possible because when it hits 3 we're resetting it anyways. Okay, so that one's redundant as well. Elif I position tracker equal to, oh, it's got to be equal. A little syntax miss there. Equal to 2. Okay, equal to 2, so this one should be easy. Digit equals num modulo 10. As final answer equals O tens digit plus space plus as final answer. So this is if we're in the tens place, and obviously this is only for the 20 to 90 scenario. Yeah. Or wait a second, wouldn't it be easier if we... I have a thought. What if we just keep adding and then here we do like an if digit equals 1, then remove the last digit? Yeah, I think that makes more sense than just having a separate condition altogether. Yeah, if digit, so then if digit not equal to 1, then as final answer. Yeah, it's plain and simple. Break, what a break? No, continue. No, okay, yeah, we're gonna use an else just to be smart here. Position for add 2, so why don't we just position tracker equals 3 just to be extra safe. Number equals number floor division by 10. That should be all. And then else digit equally, oh, there's another else, elif digit if number not equal to, okay, wait, if digit not equal to 1 and digit not equal to 0. Yeah, forgot to account for the 0. Did I? Oh shit, yeah, I did forget to account for the 0. If num greater than 0. Okay, yeah, this is if digit not equal to 0. And I keep... Yeah, that makes sense. If digit is not equal to 0, else if the... Alright, I guess we can just do else num equals num, then what is this? At 3i position. Oh yeah, forgot about that. Wait, okay, so if we're if the number we've hit is 0, then we don't do this part because no one ever says 0 million. Yeah, so yeah, this part is redundant as well. Yeah, my bad. Okay, so if digit not equal to 0, then we do that. Then we move this back 1. Yeah, makes sense. So if we're at the 100th position, so if it's like 1 to 7, so we just add 100 whatever, 61,000, yeah. If that was a 0, 0, then we would skip and it would be 100,000, yeah. So this would be 100, 900 plus whatever. But if it's a 0, then we don't care about this 100 part. We just directly divide the number by 10, change the position tracker to 1, and if the number is greater than 0, which means there's something left, then we add the 1,000, million, or billion. So in that case, if it were like 100, like let's say it was right on 100, okay. So up until this point, we've already got whatever is behind, like we've already got 1, 2, 3, we've already got 1,000 in there. So it's 0, nothing, 0, nothing. If it's 1, so that would be 100, whatever is 1, 2, 3, 100, 123, 123. If it's 9, it's 900, 123. If it's 0, it would just be like 1,123, right? So we skip the 100. Yeah, so do this. If we got something left, that's perfect. At the 2's position, we divide, and if the number is not equal to 1, and the digit's not equal to 0. So let me just think about this. If we're at 101, so if the digit is like, let's say 120, 131, 41, 91, so 191. So in this case, we just add 20 to 90. Yeah, so equals, yeah, digit plus final answer, the 1 already covered, 20, 30, 40 already covered, 100, yeah. We're oh yeah, something, no, we don't. Oh, something I forgot about here is all positions equals positions from the first index onwards. Yeah, So we're cutting out the 0th element. Yeah, forgot about that. If we're at 2, we don't care about the positions, so if the digit is not equal to 1 and not equal to 0, this part would happen in any case, so I don't think that it needs to be in the loop. Elif digit equal to 1, then it would help to have a buffer, but I don't think it's necessary. As final answer equals as final answer, the string. We're going to convert it into a list. Dot strip out all white spaces. Dot split it on spaces. So this whole thing is the list. And then we're going to cut out that first element, but I need what it is. I need what it is. Oh wait, there's an easier way. What if I just jump the position? Wouldn't that make more sense? Yeah, I'm thinking, what if, let's for a second here, just, I don't know what I was doing here. I'm gonna digit equals 0 just so I know. Yeah, so I'm saying, what if it's like elif I position tracker? Yeah, that makes more sense. Equals 1. So digit equals num modulo 10. Makes sense. If num modulo 10, no, sorry, if number floor division, I don't know why I'm putting this, no, I want to put this is greater than 0, that means there's another digit. Greater than 0, and if number modulo number whole divided by 10, which is the next step, modulo 10, if number is the next step, and then if that digit equal to 1, aha, O doubles will just be, we can just do that, and that makes sense. It does make sense. Right, so think about it. If if the next digit is 1, then as final answer equals O doubles digit, which was the earlier one we got, plus space plus as final answer, right? And yeah, if it were 1, so we were at the 1 position, and yeah, that makes so much sense. I position tracker equals 3, right? And num equals num divided by, sorry, yeah, floor divided by 10 is what we, is removing the ones place and taking us to tens, removing by 100 is removing the ones and the tens and taking us directly to the 100th. Right. And if there's nothing, then it would just be 11,000, 11 million. Yeah, works. Okay. And if there's nothing above that also, it would just be 11. Right, that works. So well. Okay. But that step, no, that step is different. So okay, I'm back, and it was like a 1-minute breather. So I was saying that I'm onto something. So this is the 11th scenario taken care of, and now it's just the one scenario. Wouldn't the 10th thing be similar, I guess? Yeah, because that would make the, yeah, that would make the next step a lot easier, actually. So if then we would have to do this calculation twice, and that would take some memory. Okay, let's just copy this as is for now and paste it. Else if next number would be 0, then we would do the same thing for tens. Makes sense. And position tracker would jump accordingly. I think it would make more sense if digit less than 2, and then just put this whole thing under that. Yeah. And I next digit equals this. Control C, Control V, and then Control C, Control V. Next digit greater than, no, sorry, this is, yeah. I remaining number equals this. And I next digit equals I remaining number modulo 10. Yeah. So we would put this right there, and we'll put this right here. So I don't know if I'm null checking this, but there is a while num here, so technically it's null checking it every single time. Oh yeah, and I don't have to do anything extra either. Cool. So if we're at the ones place, so if the digit is less than 2, else s final answer equals ones digit plus space. But then that space could be an issue. So then what if we do it with the oppositions, right? Yeah. But then the oppositions would be an issue. Okay, dot strip. Simple. I mean, then in that case I could just do that. Makes more sense. Yeah. Yeah, makes sense. Okay, so S final answer plus 1 digit plus S final answer, which should in the starting be nothing, correct? So in the end you strip it and it'll just be 1 or something. Okay, so this is the ones position completely done. Oh, no, it's not. Num equals num floor divided by 10 and I position tracker equals 2. This would make more sense to do that first, just for the sake of consistency. I'm gonna trust this bit of code for now. So then we're gonna come up to 2, and I think we don't have to do anything, right? So this whole thing can just go and get deleted because we're skipping 2 in these special conditions. So we can just do this, copy this, as final answer equals O tens digit plus S final answer, and then this becomes 3. And when you're at the 100th position, yeah. Let's run this, see what comes of it. Unexpected indent. Run. I assume it's not gonna pass because of small things like this. Equal. I mean, I assume it might not pass because of, what am I missing here? Key error. O tens digit. Why would I have thought that this is how I'm gonna do this? Okay. I mean, figure it out as we go on, right? I'm thinking memory error is probably what's gonna happen here. And that would be a problem, because I feel like this is something that would work. So it took too much time. Why did it take time? That's the question. That's the big question. It shouldn't take time because it's just iterating a very small amount of characters, unless the time limit's really small. Time limit exceeded. Okay. So we're only iterating over 1, 2, 3, 4, at most like a billion, whatever the digit comes out to. So I think that the issue would lie with that split strip. Oh wait, and I'm not even doing it. So okay, while num if position tracker is 3, or if it's 2, or if it's 1. Okay, cool. If it's so we could flip the order, but that wouldn't make a difference, right? So if it's 1, it if digit is less than 2, let's assume it's not. So then it directly does this. Num position tracker equals 2. This shouldn't be so bad, I think. Time limit. Okay, well let's take a hint. Okay, I got that part. Okay, I also got that part. I got all that, but I don't know if final answer equals str1's digit. Is that what I'm doing wrong? Is that, I mean, I don't, this is not gonna make a difference because those are all strings. I mean, obviously this is not gonna make a difference. If digit as final answer, okay, it's also not gonna work. Time limit exceeded, how so? Is there a way I can test this without the time limit, just know if my algorithm works? I would love to know. If num equals 0, return 0, that's something that should not be an issue. O1s is this dictionary, O10s is this dictionary, O doubles is this dictionary. Let us try a somewhat, let's ask ChatGPT. Let's keep that hidden. Is initializing dictionaries in Python a costly operation relative to Python? Our initializings is not a particularly. Okay, so as per ChatGPT, this is not gonna take much time. There's another way we could do this, but I don't know that it's not worse for sure. What if we just convert this into an array and we just delete all of that and then we keep an empty element at the beginning. Because that would handle the 0, right? Yeah, so that's an array. I don't know if this is gonna work, but it's not the dumbest thing I've done. I mean, I've learned that software engineering goes wrong at every step, so the fact that I got the algorithm is, if nothing else, very cool. This might break, might not. Okay, this is something I don't need. I don't know if that's like the thing that's pushing me over the time limit, but that was like a typecast and a length. Calculate. Okay, it says time limit exceeded, but I don't see. Okay, what about What about if variable? Okay, so this is fast as well. This is fast. If variable equal to 2. Oh, it's given me something to... Very fast. It's very fast. This if condition, this if condition, this if condition. If number is greater than 0 is the same as if number. I don't know if that's doing anything. If position tracker, if equals, if digit, if elif. Okay, what if I just remove this line from everywhere since I'm doing it almost? Nope. Okay, yeah, wait, what if I remove it from everywhere? Since we're doing it everywhere. Pretty much. Right? I mean, it shouldn't make any difference because we're only doing it once. While no, so it's gotta be there. Num equals num divided by 10. I don't know if this is improving anything. Oh. 10 to 100. Okay, well, somehow that did it. I think we can get rid of this line as well, since we're doing it. If num equals, okay, so we're definitely somewhere. We're definitely somewhere. Okay, so what did I get right? 123, 123. Okay, so 1000 to 10 to 345. 345 is correct. So the 1000 part is what went wrong. 1200. Whoa, okay. 1200. What? Okay. 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 So I think wherever I'm updating this is where I'm going wrong. Let's think about it. So 567, which means we reached 500 and then 67 was already in there. Position tracker 1. And then if there was something remaining, which is yes. Opposition 0, which is nothing. Ah, which is nothing. Oh, right, we don't need that because we're already tackling it. Right, so this should work. Okay, I stand corrected. Do I stand corrected? Okay, definitely. What are we getting? 10 to 1,234,000. I think we can get rid of that. I hope. that wasn't something in the code. I think we can get rid of this because the extra 1,000 doesn't mean that this is broken. It means that this is broken somewhere. Aha. This is probably correct, because we want to check what's remaining. Okay, well, at least the first case works. Second case, what are we? 10 to 10 to I'll get to in a second. 1 million. So now is the question of why that 1 million isn't happening. Okay, let's tackle this 10 to real quick. If position tracker equal to 1. Aha. Aha? No, not aha. Not aha. Oppositions equals oppositions 1. That part shouldn't be wrong, I guess. What if I do that? Oh, I'm sorry. If I do that, will that make any difference? I doubt. It won't. Okay, so this part is broken though. O10s. Oh, obviously. Okay, I see something that's broken here. Yeah, very much. Yeah, bro, this is very much incorrect. Okay, so if digit is less than 2, yeah, that's what. If next digit equal 1 and digit not equal to 0, else if next digit if digit, this should fix the 11 issue. Didn't 10 do? How is 10 getting triggered? Let's figure that out. 10s can only get triggered through here. No, that's not even possible. So wait, this is happening if digit equals 1, which is fine. Okay, so no, the issue is when digit equal to 2. Digit less than 2, as if. Oh man, I'm not that smart. Okay, yeah, there's a big miss here. If digit, okay. I think this is gonna be an unfortunate. Okay, so if next digit is less than 2, we need to add a null check here, actually. Actually, I guess it doesn't matter because this would become 0. And then this would fail anyways. No, it would, no, it would fail. If I remaining number, yeah. If I next digit less than 2, if, so this part we're already checking above, so I'm just gonna move this all back here, get rid of this check. So if the next digit equals 1 and the current digit is not equal to 0, so then we do doubles. Else if digit this doesn't belong here. Yeah, that doesn't belong here for sure. Okay. I'm now realizing that it's a little bit more complex. So what I'm wondering is like, what happens if the number is like 0, 1, 2, 3, 4, or 0, 1, 2, 3 I think is better in this case. So if position tracker is 1, we pull out digit, and if remaining number does not exist, let me think about this. Okay. Oh, let's say we're at 1 digit, we pull out the digit, and we figure out that there's no remaining number. Alright. So then we just return whatever, which would be this. This part definitely makes sense, because if the next digit is less than 2, this is the 11's case, and this is the 10 to 90 case. So now what's remaining is just to the 1 to 3, 4, 5, 6 case. Yeah. So this is correct. Else this 1, 2, 3, 4, 5, 6. This is only if the current digit is not 0 though. Right? Yeah, cause okay, yeah. So what's happening I think is well, I'm not sure what's happening, but I think there's a condition that's like not being covered properly, which is that the current digit is 0. So if the current digit is 0, what if we I have an idea here. What if we just put this? I don't know if this is gonna work. It might run. Okay, that works. So, let's try submitting this and see if that works. If next digit I is not associated with value, I next digit. Ah, right. So this whole thing should come. What was this stupid miss? This whole thing comes under this, I would assume. But I feel like I'm missing something here. Am I? What about the zero case? Because I feel like I'm missing that. What? I don't think this is gonna be correct even if it works. Yeah, this part is definitely not correct even if it works. We're missing we're very much missing something here. Let's say you hit the first number. If it's, so you pull out the digit and you check is there something remaining. And if there is something remaining, then you check out what the next digit is. I don't think I need this. Do I? Okay, no, I do because it's right here. And if the next digit is less than 2, meaning it's 0 or 1, we don't care about 0 actually, right? Because yeah, we don't care about 0. Yeah, equal 1. Yeah, that makes sense. We don't care about 0 here. So, okay, yeah. Yeah, that makes sense. So, if we pull 1 and I think we can get rid of this if remaining number of this. If next digit equals 1, then we can push all this there, which is the 11th scenario. Yeah. So this is all for the next digit. And this else is if there's no remaining number, we just add a 1. But that's if remaining number okay, so we're missing the scenario where there is a remaining number, but although it's actually that's not what we're missing, but in my mind we're missing the scenario where there isn't a remaining number. No, we've got that in place. I think we're missing the scenario where there is a remaining number, but it's not 11 or 12, right? I think it makes more sense to do that, yeah. Just push this back here because this code gets evaluated in any case, right? Yeah. So if the digit is 1, we check what the digit is, we check if there's a remaining number, and if there is a remaining number, then if there isn't a remaining number, then we just do this. But if there is a remaining number, what if we do a little bit of, I forgot what this is called, I think it's called condition guarding. This is not the best piece of code. You guys are because we're making this calculation like thrice. Do we care about remaining number? Actually, we don't, right? We just care about the next digit. No, but the next digit is an issue because if this is 0, then we want that to fail, because if we do next digit, it might come out to 0 anyways. But if it does, you can just strip that out. You don't need to add it, right? Right, that's what I'm thinking. So, if the remaining number, we don't care about that actually, because in the event it's 0, we're gonna skip it anyways. And the next digit is also, okay. Let's think about this. 0, 1, 1, 1, 21. Simple. There's 3 scenarios. One is that the next number is 0. Oh, okay, actually there's a couple more scenarios. 0, 0. And we can just expand this a bit. And then there's 1, 0. Okay. Yeah, so there's... Yeah, why don't we just... Okay, so in this case we want to skip to the 100. In this case we want to skip to the 100. And in this case we want to skip to the 100. So that's 3 cases where we do the same thing. We skip to the 100. So... But then we would add more conditions for the ones where we're not doing it. Yeah, but these two... Oh yeah, wait a second. These two are the same thing. Aren't they? Yeah. So what about 2-digit? Yeah, so we're assuming that a 0 never hits here, because we're taking care of that here. So yeah, let's figure this out. There's a couple of... You know what, do we want to rewrite this whole thing? I think we might be better off rewriting the whole thing. Oh, okay. How do you comment it out? Okay. I mean, I could just... Let's just move this to somewhere. Keep this safe. Do not modify. I don't want you to fix anything. I just want you... Okay, fine. It's fine. We'll figure it out. Okay. There's a few scenarios. So let's think about this. 1, 2, and 3 we want to jump anyways. So if, no, so first we need the digit equals num modulo 10, and do we need the next digit here? Okay, let's think about the happy path first. If digit not equal to 0, okay, so if digit not equal to 0, we run this, but then we need next as well. So I remaining number no I next digit equals what the Python expression for a equals num double slash 10, now this modulo 10, but if num is 0, then make a -1, something like that. Yeah, ternary condition, I forgot exactly what those are. Yeah, so this works for me, because yeah, so what we're doing here is num, we get the next digit if yeah, that works, else -1. Okay, so first things first is if, okay, so these 1, 2, 3 are only in the 0, 1. If next if I next digit less than 2 and current digit not equal to 0, greater than 2, so that's these two conditions. Or if I next digit equal to -1, so that should be, yeah, that's this condition. Oh no, yeah, oh yeah, that's, there's one more condition I forgot about, which is that we're at the last position. Okay, I don't know why it came out like that, not so smooth. Yeah, so this would also be that same thing, because we just want the digit itself. Okay, cool. So if I next digit is greater than 2, no, greater than 1, and digit is not equal to 0, digit is greater than 0, if digit and digit if that, or there's nothing left. Simple. S final answer equals ones digit plus space plus S final answer. Okay, simple. Else what have we got? Okay, else. So in any case we want to skip 2 positions. So in this case we're gonna do num. Did I remember that code? Because I didn't want to. Yeah, I forgot. Okay, my bad. Else pass. Yeah, so in this case we're gonna be doing num equals num divided by 10, floor divided by 10 in any case, no matter where we are. Yeah. So here we would just be I possession tracker equals 2. Num is gonna be incremented. Okay, cool. Else if I next digit equals to 1 and digit not equal to 0, S final answer equals O tens digit plus S final answer. Makes sense. Num is gonna be changed anyways. S position tracker is gonna be double jump anyways. Else elif I next why we could nest this, because that would be one comparison. If digit oh, sorry, my bad. And digit not equal to, that's the 11th scenario. And the next is elif digit equal to 0, and we don't care what I next digit is, but oh no, we don't. Okay, no, 0 0. Okay, so if it's 0 0, that means I next digit is 0. So the only thing, yeah, the only thing we want, okay, yeah, the only thing we want to do is jump to the 100. Okay, cool. This is what I was thinking about is, so right now we're handling 0 0. Can probably zoom in more. Right now we're handling 0 0 1 1 1 0. So if the digit is 1, then we have the respective dictionaries, and we jump 2 positions. And for this, we just jump 2 positions, right? So works. Then so we got doubles and num equals num floor division by 10, I position tracker equals 3. I think this will run in any case. I hope I didn't break something. Okay, 20,345. Okay, so we're actually at 1, 2, and it thought we were at 2, 0. How would that happen? So when it hit the 1,000, it must have done this. So it did this. 1, 2, 3. Okay, cool. Okay, cool. So it did 1,000, then it split, it spliced, and then it changed position tracker to 1. So then we come to this scenario. Okay, and then we split. So then now we have 1. Num is 12, right? And position tracker is 1. So position tracker comes to 1. So digit is 2 if next digit is 1 floor division by 10 modulo 10. 1 floor division by 10. Wait, sorry. We're at 12. 1. 1 if 1 else minus 1. So we're at 1 if 1, which is true, so 1. I next digit is 1. So if I next digit is greater than 1, that's not going to happen. So else equal 1 and the digit not equal to 0. O doubles, O tens. Run. This should fix it, I hope. Okay, 0 millisecond. Would you look at that? Submit. I hope something doesn't break. Okay, so I would love to see the test case that failed. Okay, so the number is 1, 0. So while num position tracker is 1. Okay, so elif position tracker equals 1. Digit is 0. Next digit is 1 if 1. So if next digit greater than 1, false, and digit false. Okay, so else it goes into the else. If next digit equals 1 and digit not equal to 0, false, because digit is 0, else digit equals 0. Correct. Ah, okay. Next digit. Smart. I mean, this would obviously work, but submitting it should hopefully fix more test cases. Really? What broke this time? Is that a typo? 70. Probably review all the typos. 10, 20, 30, 40, 50, 60, 70, 80, 90. It's a little indent off, but whatever. 11, 12, 13, 14, 15, 16, 17, 18, 19. 1,000 million billion. Looks good to me. I think 1, 2, 3, 4, 5, 6, 7, 8, 9. Looks good to me now. So let's go through these issues one by one. 101, and it gave the output of 1. That shouldn't happen, but okay. Number equals 101. So position tracker is all the way at 1. So, did I not cover that? Okay, so digit is 1. Next digit is 0. Next digit is 0. Okay. So if I... Ooh. Okay. If I greater than 1 and to if next I next digit equal minus 1, else 3. I think this would fix it, or maybe I might have to flip it. Okay, I might have to flip it. No, it shouldn't. Okay, wait. Let's check with ChatGPT. What will this Python line do and when? If next digit equals minus 1. It should be the other way around, yeah. Yeah, it should be the other way around. Yeah, it should be the other way around. Okay. 101, we're still failing here, okay. Okay, so 101, so digit is 1 at position tracker 1. Digit equals 1, next digit is 0 if 0, 0 if 0, 0 if 0, is that true or false? Wait, what is it? Yeah, that equals 0 if 0 else. Result would be 1. Okay, 0 if 0 else minus 1. So 0 if 0 else minus 1. So the next digit comes out to minus 1. No, wait, sorry. I next digit equals 0 if 10. 0 if 10 else minus 1. So that would be okay, so 0 if 10 else minus 1, so the next digit is 0. So if the next digit is greater than 1, no, else next digit equals 1. And and current digit, okay. So if next I think that is incorrect. Yeah. Elif I next digit equal to 0 and digit not equal to 0 as final answer equals O1s plus space plus as final answer. I think this works because you're skipping. Is this wrong? Oh, sorry. O1s digit. Yeah, my bad. I passed more test cases. Okay, so 100,000 was an issue. Okay, 100,000. 100,000. Okay, I see what the issue is. That means double zeros, right? Okay, so let's see. 100,000. Position is 1. So digit is 0. Next digit is 0. So we're at 0, 0. We're at 0, 0. Okay, so numbers, I believe 0, 0 comes into this bracket because you're jumping 3, so I think that would just be in the let's try this. I don't think it would make a huge difference. Oh, it did. 1,000,000 and expected is 1 million. So, oh, okay, right. This is interesting because I'm appending this. There's an interesting way to do this. Positions, and then we can have delete. But then that would actually bump up the complexity a lot. So I'm thinking these are like keywords. If you see these, then we just... Okay. How did this not trigger though? Oh, okay, right, because we had that 100 thing. if as final answer, if the length of this is 1 and as final answer in or delete then we want to, if not this, then we continue as actually no, I want to do it the other way around. In O delete if length as final answer equal 1 and the answer is in O delete, then what I want to do is as final answer equals O positions 0, else in any other case that submit. And then yeah, we splice it at the end anyways. I am somehow this is a point. Okay, so it comes here and it's been 0 0 up until this point, so it basically is jumped from the first step and it sees 0 again. So if digit is equal to 0, okay, so then else, if that will give us like 100k, so 10k, if length as final answer equals 1, which should be true, and as final answer in O delete, oh okay, wait, dot strip in O delete, this might work now. No? Okay. In O delete. Okay, so it's clearly failing this condition. But why? Dot, I mean this is the only debugging I can do here, as final answer space dot, and then I submit this again and it fails, and it does it show me my output? Test result. Does it not show you the output? Use test case. Okay, cool. Yeah, run. Let's run this. I forgot how you check the test result. I'm like 100% sure you could definitely, but I don't remember how. But fine, if I can't debug, then I'm just gonna do it the hard way. Okay. So this is... Oh, I see. Okay, this might not be a good idea because it's pretty costly, but this is a very costly operation actually. Okay, I see. List final answer dot split. This might also not work, right? This is a pretty costly operation, so I think it would list split. Oh, okay, sorry. Cool. Run. I think this is not gonna work, and if it does work, yes, same thing. Dot strip dot split. What if we do that? Dot strip dot split. I think it might work now. It's a very costly operation, but we can try it out. This is not the best way of doing it. Okay, we're at the last 6. 1,000,010. Okay, 1,000,010. There's an easier way of doing this. Okay, yeah, this is a bad way of doing this. Yeah, if so right now num, so currently we're at the 100th position, so this is the 1,000, right? Which is the next one, next 2, next 3. But this also screws you up, though. What about this? Right, let's run this first, because I think this might fail the millionth. Oh wow, it's failed a bunch of stuff. Currently we're at the 100th. Does this make sense? I just want to add this test case to my suite. Let's see. Okay, so it works for the previous few, but it doesn't work for my 1,010. Okay, let's see, why would that be? I mean, I know why that is, because it's running this. Okay. So can we do like an Python compiler? Compiler, okay. One thousand print 1000 divided by 1. No. 1,000,000. 1 print run. This should give 1. Yeah, so 1,000,000. And we're currently at the 100th position. Okay, so as of right now, this is the value of num. Is it? Yeah, it is, because we're double. Yeah. So 1, 2, 3. This is the value of num. And let's say we're checking what the next 3 digits are. So oh, right. This is what I would want. Yes, simple. And no, percent. Run, this should work. Submit. I cannot imagine that there's an edge case. There seems to not. This would be my easiest fix. Because, yeah. Last test case, okay. So expected is 100,000,100. So I mean, this is the... I don't imagine this would break it. Oh, it would. And if I remove this, does it break it still? Nope. Okay, cool. Okay, so we're adding 1,000 when we don't want to be adding 1,000. And we're adding 1,000 at this position where 1, 2, 3... What is that? 5. So our 5 zeros are not covering it. Something like this, I imagine. Because you want to... no, okay, very much not. I was thinking it's like you're checking the remainder, but you're also checking if there's a number there. Okay, so 100 million means we're quite a ways away. Okay, let's think about this. That's many zeros away, and we could just add zeros, but that wouldn't work. Okay, well, here's the thing. We know that the constraints are how many digits? So basically when you're adding 1,000, you only have to check, will there be a million? Will there be a billion? And that's 1, 2, 3, 4, 5, 6, 7 digits that are not 0. And 10,000 covers, okay, so wait. 100 million is 1, 2, 3, 4, 5. So 100,000 would have fixed this, but why is it not working? That's the question. That kid, by the way, probably, I'm pretty sure his video wasn't this long. But hopefully I was recording this whole time. Yeah, I was recording. What if I do like OR conditions or something? Because I know the constraints. So there could be like 2, 1, 2, 3, 4, 5, 6. Yeah, it's 6 zeros is the max there could be, right? Because before this is already covered. So 6 zeros, out of which 5 are already covered. So basically I'm just checking if the 1,000 position is good, which it isn't, and therefore that's 1,000. Wait a second, that doesn't make sense, because if it said 100 million, it said 100 millionth. Let's just copy this. So this, and we're at this position. So 1,000. Okay, so we're at this position. We've added the 100. Ooh, what if we don't? What if we just jump directly from 3 to 3? Wouldn't that adds complexity? But yeah, what if we just do that? What if we jump from 3 to 3? I mean, it's one case, but still, like, that would make a bit of sense, right? Because give me a sec. Okay. Okay, back. Because what if? Yeah, that kind of makes sense though. Like, instead of doing this, what if we just do like, or no, let's do 100. 100k, run, 1000. Yeah, so it'd be like this, run, 100. Okay, cool. So what if it's like, if num I'm thinking like num 1000 not equal to 0, then something like this, else num num 100, something like this, because that would just jump you to the next one. But then in that case you would be doing this in any scenario. I think it would be like this because we're trying to jump one. It's definitely something I'm getting wrong. Oh, okay, right. I think this might be what's wrong. I'm thinking, what if it's like... something like this. Then if this is not equal to 0, then you add the 1000 or whatever. You change it once. Else you just jump up and the position still stays 3, right? Because you're dividing by 100, so you're jumping to 1 tens, and then from tens you're jumping to the 100th. Yeah, but I don't know if I'm doing it right. And you just jump up 1. So as per me, this should make sense. Okay. I mean, Okay, what about speed, huh? Did I... Oh, look at that. Runtime beats 100%, huh? Makes sense. So there you have it. I don't know how long that was, but cool.